Once again, a very good morning to all of you. And today we will discuss mainly about the first thing or the only one thing better to say, that is elastic potential energy. So elastic potential energy. That is what we are going to study today. So in a short form, you can write it as EPE, elastic potential energy. First thing you need to understand here, what is the meaning of potential energy? So, what is the definition of potential energy? Potential energy means the energy gain, or loss. Energy gain means increase in energy. Energy loss means decrease in energy. So the energy gain or loss by a body, due to change in configuration, due to change in configuration, due to change in configuration. So the energy gain or loss by a body due to change in configuration, we call it as potential energy. For example, what is the meaning of configuration? Position should change. Suppose the pen is here. Look at my hand. Now I took it to another level. Now what I change? Position. But to change the position, what we have to do? We need to apply some force. So you apply some force and you have to displace the body. Displace the body means what? You need to move the body from one position to another one. So that what we call it as work done. Because work done means force into displacement. So work done here is force into displacement. And whatever work you are doing, so that work will store as some energy. So that work only we call it as what? Potential energy here. Because you are doing some work by applying some force. And that work is utilizing in what purpose? To change the configuration. That's why we call it as that work will be storing as potential energy. But here in this chapter, in mechanical properties of solids, we are not talking about the position shifting. I mean moving from one place to other place. We talk about three things. One is change in length. Now you take a wire and you apply the force. So you pull from both ends like this, then stretch will happen. So change in configuration. Change in configuration, nothing but in terms of length. Or else you take a spherical body and put it inside the liquid, then there is a change in volume. So this is delta V. So volume changing means that is also called what? Change in configuration. Or if you take a body like which is fixed at the bottom, now if you apply a tangential force, then position got shifts by some angle. So there is a change in length configuration, there is a change in volume configuration, there is a change in position configuration. So in three different cases, we have three different type of change in configuration. But in every time, in every case, We are applying some force. So you apply some force. What force we call it as? Deforming force. So in this chapter, whatever force we are applying, we call it as deforming force. So here you apply deforming force so that there is a stress, so that there is a change in configuration. Nothing but that only we call it as what? Strain. That means work is done. Work is done. And that work done will be stored as potential energy. But here this is related to, as it related to elasticity, the property of elasticity, we call it as, elastic potential energy. Not in this chapter, in any chapter, if you do some work by applying force to change the configuration, we call it as, we take that work as equal to potential energy, because work done in changing the configuration always stores in the body as potential energy. That's why here we call it as the work done in changing the configuration as potential energy. But why we named it as elastic potential energy? Because here we are dealing with elasticity. That's why we have named it as elastic potential energy. But in our syllabus, we don't have all the three cases. In our syllabus, work done, we calculate only in case of Young's modulus. So, what is that is work done. Young's modulus case, when it comes, when length changes. Length of whom? Length of wire changes. That's why first what we calculate is work done in STRE, stretching a wire. Work done in stretching a wire. That we will calculate. That is the only thing is there in our syllabus. We will not calculate what is the work done in case of change in volume. We will not calculate what is the work done in case of shear stress. Only we calculate in this chapter work done in case of longitudinal stress. So that is the main thing. Now the question is how to calculate work done. So first thing, as we have just before seen, the very first thing is work done formula is force into displacement. For any external force, when you apply force and the body got displaced, then the work done general formula is force into displacement. Now you consider in this manner. Consider this is a roof or fixed support from which one wire is hanging. From which one wire is hanging. Now here one force I applied. Then what happens? As you apply force and pull it down, the length what happens? Increases. So let's take like this. So that this is the new length. Let's take initial length as L. Initial length as L. Now the final length is how much? L plus delta L. L plus delta L. So the initial length is L. Final length is L plus delta L. That means what is delta L? Delta L is change or increase in length. Change in length. Now here work done we have to define. So for that we need to understand one concept. See, that thing actually you will study in detail in another chapter called Center of Mass and Rotation Motion. But that we will study later. That is track 1 part. So, but you will study after 2-3 months that thing. But right now in this chapter that is important to understand this one. What is that is here? I will tell you, please try to understand. Center of mass means a point where all the mass appears to be concentrated. See here, let's take this pen. Are you able to see the pen? Please look at my hand. So, see here, now what I am doing, I am balancing the pen at one point. Are you able to see? Raise your hand. Okay. Now, so here, when you are balancing this one, at one point, that point we call it as what? Center of mass. See here, the mass is there throughout length, but by balancing one point, you can balance the whole length. So such point, what we call it as? Such point we call it as center of mass. Means that is the point behaving like the whole mass, all the mass is concentrated here only. Such point we call it as what? Center of mass. For every regular body, for all the regular bodies which are there in our syllabus, for all the regular shape, center of mass nothing but geometrical center only. Geometrical center. Like if you take a sphere, where the center of mass will be there? At the geometrical center. If you take disc, ring, at the center of mass will be there. If you take a rod, where the center of mass will be there? At the center, at the midpoint. So why I am studying? Why we are studying this concept? Because see here, I will tell you. Now, like you consider now, see this is now one wire. Now where the center of mass will be there? The total length L. Now center of mass will be at a depth L by 2 at the midpoint. Now you pulled it by some force so that now the total length became L plus delta L. Now the center of mass will be here somewhere. Now the depth of center of mass will become L plus delta L by 2. Please understand the point. The center of mass lies at the geometrical center. Center means half of the length. So L by 2. But now when you apply force, the new length will become L plus delta L. So that now the new position of center of mass will become from the fixed support L plus delta L by 2. So if you consider this is initial center of mass, now this is final center of mass, and this position is L by 2 and this position is L plus delta L by 2. Now this is X. What is this X? X is displacement of center of mass. Because for every continuous body, we need to consider which point displacement? Center of mass. That's why I said what is center of mass. So the displacement of the particle, this rod or wire means displacement of the center of mass. So now from the diagram, see this total value from here to from here, the distance is L plus delta L by 2. Now this is from here to here L by 2. Now what is X will become from diagram? This is L plus delta L by 2 minus L by 2. If you calculate, if you take LCM, so L plus delta L minus L by 2, L cancel. So it will become delta L by 2. So finally, what we get it is center of mass. Center of mass displacement. So once again, just try to revise it and try to take screenshot also. Because I cannot send these notes, please take screenshots. First, what is the meaning of elastic potential energy? What is the meaning of potential energy? Potential energy means the energy gain or loss due to change in configuration. But here we have three different type of configuration. But in our syllabus, we calculate work done only in one case. What is that case? Work done in stretching a wire. So that work will be storing as what? Potential energy. But as it is related to elasticity, we call it as elastic potential energy. So take this screenshot also. Now, next page. So if you consider a wire hanging from a fixed support of length L, then if you pull it by a force F, then what happens? The length increases. Now the final length, what it is? L plus delta L. But displacement of the rod means you should not take any one point on your own. Which point you have to take? You have to consider center of mass. So what is the center of mass meaning? A point where all the mass appears to be concentrated. Even this writing pad you consider. At one point I can balance this. So at one particular point I can balance everything means what? So now that is the point behaving like total mass is there only. Total mass is not here only, but it is behaving like that. That's why it is called center of mass. So take the screenshot of this also. Now, so now here we calculated what is the displacement of rod. Nothing but displacement of the center of mass. So here displacement of rod, nothing but displacement of rod or wire, anything. Displacement of center of mass. So that we calculated what is the displacement? L delta L by 2. Now, so finally what we have done is we applied a force and we displaced the body by delta L by 2. So what is the work done? Force into displacement. So F into delta L by 2 or else half into F into delta L. So that is the work done. That is the work done. So work done in stretching a wire. Now we got work done. Okay, fine. Now this work W equal to half into F into delta L, that will store as potential energy. What potential energy? Elastic potential energy. So what is the elastic potential energy gain after stretching the wire or rod is half into F into delta L. So this is the direct formula. What is this? Elastic potential energy. But here, one more thing also they will ask. They can ask in the question what is work done or what is elastic potential energy. So they can ask work done or elastic potential energy directly. Or sometimes they will ask one more thing related to the same thing, that is energy density. What else they can ask? Energy density. What is the definition of energy density? Means energy by volume. See, you have seen density formula once. So density means what? Mass by volume. That is actually mass density. That is what we use frequently. That's why we don't specify mass density. We simply say density. But here energy by volume means energy density. Energy by volume. So energy density. So mass by volume is mass density. Energy by volume is energy density. Like that, any quantity by volume, you can define it as that quantity density. Just 1 second. So now, what is that energy density formula we need to find? Here we are dealing with whom? Wire. We are dealing with what particle? Wire. So wire means what shape? Cylindrical shape. So it is what shape? Cylindrical shape. So cylindrical shape means this is circular area, that is pi r square, and this is length of the wire or rod. So what is the volume of a cylinder formula? Volume of cylinder means pi r square L or H, length or height. So that here volume means pi r square means area times length. Area times length. So what is the volume? Area into length. Now what is the elastic potential energy formula we got? Half into F into delta L. And what we have to define now? Energy density, small u. Energy we represent with capital U. Energy density we represent with small u. So small u equal to what? Energy by volume. Energy means half into F into delta L whole divided by volume means area into length. So this is the energy density. So that U equal to half into force by area times. Here force by area. Another one delta L by L. But already we have studied already. In case of stretching a wire or rod, force by area means stress. Delta L by L is called strain. So what is the formula we got it? Energy density means half into stress into strain. So that here I am writing U equal to half into F into delta L by A into L. That is nothing but F delta L by 2AL, or else stress into strain divided by 2. So one more formula also we have taken. Now they will ask question directly. They can ask what is the work done or what is the elastic
It's
potential
11
energy.
hours.
or what is the energy density? They can ask direct question. So you don't have to bother much. So first kind of question they can ask direct question. But this energy density only we can define in another way. See, energy density, how can we manipulate is here stretching a wire, that's why what will come? Young's modulus will come. So Young's modulus means what? Stress by strain. Stress by strain. So Y equal to stress by strain. Now from this take strain this side, then Y into strain equal to stress, one equation. Or else take strain this side and bring Y this side. Then strain can be written as stress by Y. So these are the two equations. Now energy density equal to actual formula what we got? Half into stress into strain. Now that is equal to half into stress means I can write this equation where stress is Y into strain into already one strain is there equal to so Y into strain so Y into strain whole square divided by 2. Similarly, you can also do one thing that is half into stress as it is, but strain place I can write as stress by Y. So that stress into stress, stress whole square divided by 2 into Y. So stress into stress, stress square. So take the screenshot of this also. Have you taken previous one? If not, please take first previous one. Then now you take this one. Now after this, final conclusion is work done or elastic potential energy is half into F into delta L. Energy density means energy by volume or energy by area into length or else half into F into delta L by area into length or else half into F by A into delta L by L. That only half into stress into strain or else that only half into stress whole square by Y or else Y into strain whole square divided by 2. Like this the formulas are there. So based on this direct questions can come. Suppose I will give you one question. Just take the screenshot of this. Please try to solve the question whichever I tell. Now, a wire is having Young's modulus 9 into 10 power 11 Newton per meter square and there is a change in length as 0.2%. So they are asking find energy density. So for a wire, when you are stretching, then what they found is the wire has Young's modulus this much and there is a percentage change in length. How much? 0.2. Then what is the energy density they are asking? So please solve it and tell me the answer quick. Come on. What is the formula here you need to use? What formula you have to use? The formula to be used is energy density. But we have three formulas. But here Young's model is given and percentage change in length. What is the meaning of percentage change? Delta L by L into 100, that is 0.2. So that is the percentage change in length. They have given delta L by L value. So delta L by L is nothing but what? So delta L by L is nothing but strain. So they have given Y and strain. So in terms of strain, what is the formula? Y into strain whole square by 2. So you need to take the formula quickly according to the given data. So someone send me answer 0.45. Okay, we will see. See, from this data, delta L by L, how much it will become? 0.2 by 100. Zero point 0.2 means I can write it as 2 into 10 power minus 1. 100 I can write it as 10 power 2. Now 10 power 2, if it goes up, it will become 10 power minus 2. So total 10 power minus 3. That is delta L by L. This is nothing but strain. So strain value I got it. Now if you substitute here y into y is 9 into 10 power 11 strain. Strain is 2 into 10 power minus 3 by 2. Sorry, this is whole square. So now here 2 into this is 4.5 equal to 4.5 times 10 power 11 into here whole square is there. So 2 square is 4. 10 power minus 3 whole square is 10 power minus 6. So that 4 into 4.5, that is so 18 into 10 power 11, 10 power minus 6, 11 minus 6, 10 power 5. So this is what energy density. Energy density means what is the unit will become? Energy joule by volume means meter cube. So what is the unit will become? Joule per meter cube. That unit also important. Joule per meter cube. So this way, depending on the given data, you have to choose the formula. You need to do the required manipulation. Then you need to substitute in the question. Now, one more question I will give you. One last and final question. Just try to solve it. Now, a wire having Young's modulus 2 into 10 power 11 Newton per meter square. Now, having area of cross section 1 millimeter square, of length 1 centimeter or else 10 centimeter. Now, stretched by a force so that increase in length is 0.1 millimeter. Then find the work done. The question is, there is a wire and they applied some force so that the length increased by 0.1 millimeter and they have given area and they also given the length. So please try to find it and tell me the answer. What is the work done in stretching the wire? So work done in stretching the wire. Come on, do it fast. Anybody? Anyone got the answer? Anyone? See the direct formula. What is the direct formula? Work done equal to half into F into delta L. But here the problem is delta L given, but F is not given. But some other data they have given, Y given, A given, L given. Then you need to think of manipulation. So that is the problem with physics, that they may give the data such that you need to manipulate your formula, or you may have to mix two formulas together. Like in case of stretching a wire, the another formula is Young's modulus, that is FL by AY. From here, this is delta L. So YA delta L equal to FL. So F value will become what? YA delta L by L. So I can find F from YA delta L. That's why work done is half into F delta L. But F is not given. That's why in place of F I am substituting YA delta L by 2 times delta L. So it will become, sorry, this is L. Now half into YA delta L. So it will become delta L whole square, whole divided by length. But here you need to take care conversion also, as I said, area first thing. Area 1 millimeter square means 10 power minus 6 meter square. Length 10 centimeter. So 1 centimeter means 10 power minus 2 meter. Delta L is 0.1 millimeter. Milli means 10 power minus 3 meter. Now Y is given directly. Y is there, A is there, delta L, everything is there. So take the formula, substitute and try to calculate. So this way the questions will be given, that after reading the question, understand the question and then take the data properly and do the proper conversion. 60% of the question, not 60, 70% of the question in entrance will come in this manner only. Either direct formula or simple manipulation based formula. So, or you may have to mix two formulas. Like here, work done formula and Young's modulus formula. Both we are mixing. So, that is the way you need to understand the question and you need to solve the question. So please take care of such questions, and in the coming class also we will solve numericals based on everything. So this is what the elastic potential energy stored inside the string when you stretch it by a length delta L. And also one more thing we defined, that is what is the energy density. So we will continue.